Okay, in this example, we are going to design or show you the isolated footing modeling in STAAD Foundation Advanced, as well as design of this kind of foundation. For this purpose, so we can come to here, new file, or also here, also I have the new tab. Okay, and then doesn't matter. So for example, I can start from here, new file. And from here, I can select the general foundation.
Okay.
Here, I can select the general foundation.
Okay.
And then click open. Cancel this.
Okay, done.
Yeah, as you can see here, so our model is empty. And now we are going to create our geometry for isolating footing. So first of all, here I have the project name. So actually the first option is not that matter. So just you can escape. Okay. So the procedure start from here, foundation plan.
Foundation plan.
Okay, from foundation plan. So from here, as you can see, if you want to create the grid line, so you can come here. You can come here and then create the grid line, okay? But usually for isolated footing, we don't need to create our grid line, okay? Maybe for mat foundation, we need to create the grid lines, of course. But for isolated footing, because we have, for example, we want to design one footing only, so that's why it doesn't matter the location of the footing, is here or is here or is here. Doesn't matter, because later on we want to just, create the geometry of this footing. So it doesn't matter where it's located, and then apply the load, maybe some moment, okay? And then simply we can design it. So that's why, so I can come to the column position. So it is the most important thing that we need to just define the column position.
Okay.
Okay. So from here, let me also a little bit more explain about the linear grid setup. So if I come to here, see from here, I have this option. And then, so here you have actually, some options. For example, you have the origin in X, Y, and Z. So by default is 0, 0, 0, which means here, okay? So here is 0, 0, 0. Okay, and then here you have the spacing. Remember in our past tutorials, we said that in STAAD.PRO also we have the grid system, yeah. So under grid system, one of the options that we had, so it was spacing in X and Y direction, and by default in STAAD.PRO is 1 meter and 1 meter. So here we have the same thing. So here I have the grid system in X and Z direction. Okay, so if I want to change them, so from here, for example, you can change them to 1 and 1. But before doing this, another thing that is very important is the unit system. Remember, we said that we need to set up the units here. Okay, the unit system is important. That's why, so I can go to the units and make sure that, my unit is, for example, in this course or in this tutorial, yeah, so I want to have the SI unit. And then click OK. Okay, so right now I have this unit. Okay, so here spacing, we said that in X direction is 1 meter, in Z direction also is 1 meter. And then here I have the number of lines around origin. So again, same. For example, here I have the 10, 10, 10, 10. So what does it mean? Which means that here, if it is the origin, correct? So I want to have the 10 line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In this, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, parallel to Z direction. So this 2. And then this 2, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And also here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So just like this, to create the grid system.
Okay.
Okay. So again, I can accept it because right now I'm not going actually, to, let's say, create the grids, because as we said that for isolated footing or for combined footing or for pile cap footing, if we are going actually, to design a single, isolated footing or a single combined footing or a single pile cap footing, so usually we don't need to come here to create the grid system. But for now, just I'm reviewing this for your general information. Okay, and then here we have something, by default, some values. As you can see here, we have these values by default.
Okay.
Okay, and just, I can create this one here by pressing on generate. See here, I can press on generate, and it generates based on this setting that already I had done. And from here, I have actually, this kind of let's say, coordinates for grid system. Okay, so right now I have this, but I cannot see any grids here. Why? Because of this. Okay, see this right now is deactivated. So if I press on this option, see here, I can see this grid systems. Okay, so my grid system actually is too big. Okay, so here I have this kind of grid system. Okay, but you need to come here and then, so you need to actually put the a proper grid system. For example, here, I can just, select this, for example, and then I can delete it. See here, by deleting this here, you can see here, see, delete, 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 delete. Okay, and then you can create it for yourself. Okay, so then from here, for example, you can create another one. So from here, you can create another one. Okay, and from here, just, you need to put the, let's say, a proper value to create your grid system.
Okay.
Okay, so now it just, for general information for grid system. And then I don't want to see them because even I don't need them for this example.
Okay.
Okay, so directly we said that we can go to column position, and from here, so I want to have the position exactly at 0, 0, 0, which means here.
Okay.
Okay, that's why here I said 0, 0, 0. See here, I have this column position. Okay, so if you want to have, let's say, another isolated footing, so again, you can put it another one. For example, here, as you can see, I have the Z direction, and here I have the X direction, correct? Let's say, for example, I want to put another isolated footing in this direction. So what can I do? I can say that, again, X is 0, Y is 0, and then Z, for example, is 6 meters. Okay, see here, I have another footing. Correct?
Okay.
So I can accept this. Let's say I have 2 footing system, or even we can go for more. Let's say I want to also add, another footing here and maybe another somewhere here. So again, for this reason, I will say that in the X direction, I can say, for example, 6, Y is 0, and then Z also is 0. See here, I have another one here, And also I want to put another one. Let's say this time I want to have the X as, for example, I don't know, maybe 4, Y is 0, and then Z is, let's say, again, 7. Okay, see here, if I go to the top view, see from here, you can see the location of the foundation. And let's say, again, I want to create another one. Okay, so for example, here I can say that X is, for example, 7. Okay, and then Y is 0, and also Z is 7. See here, I have another one. So just I'm showing you that how simply you can create the geometry of the columns or position of the columns, and definitely, you know, under columns you have to design the footing or foundation. And in this example, we are going to design the isolated foundation or footing. Okay, so the next step, so the first step was this, yeah, column position. So the next one is column dimensions. So I have the column dimensions. Since here I have five columns, 1, 2, 3, 4, and 5. So that's why here I have 4 options for different columns. Let's say, for example, for the first column, I want to have the dimension, let's say by 0.5 by 0.5. Okay, the second one, same, 0.5 by 0.5. Okay, the third one, which means this one, I want to have the, for example, circular column. So the diameter of this column, maybe I can go for 0.6. Okay, the fourth one, which means this one, I want to have the, again, rectangle. Maybe this one I can put 0.4 by 0.6. And then the last one, again, I want to put 0.4 by 0.4. Okay, so right now, you also define the dimension of the columns. Again, from here, you can go back to isometric view. Okay, you can go back to isometric view. Okay. And if you have any pedestal, so if you want to define the pedestal, so you can define the pedestal. For example, in foundation number 1, I want to define the pedestal only. Okay, just to show you. So I can say yes. See, right now, you have this pedestal view.
Yeah.
Okay, and then from here, I can say that the pedestal height is 300 mm, which means from here to here is 300 mm. Okay?
Okay.
So here I can say 0.3. And the size of this pedestal, if you remember, if I go back to my column position, see here for the, column dimension, for the first column, I have 0.5 by 0.5. Okay, so that's why I want to create a, a smaller size for pedestal. So that's why here I will put, let's say 0.4 by 0.4. Okay, so that's it. Okay, so I just created a pedestal for foundation number 1. So later on, you can see this. So the next step is I can just close this. And then from here, I can say that step 1, okay, step 2, step 3, and then step 4. So I have total 4 steps if I want to, let's say, create from scratch. So I can go to the step number 2. From here, again, I can directly go to create new load case. Okay, here, I can go to create new load case. So under here, as you can see, I have the load case number, is 1. Okay, so it's actually, you know, by default, so we cannot change it. And then you have the load type, load title. Let's say from here again, I want to have the dead load. Okay.
Okay.
So don't worry about the self weight. So here in STAAD Foundation Advanced, the self weight will be applied to the foundation automatically. Okay. So here we want to have the, you know, some dead load, and then here, so I need to define the load type. So from here, I can say that it is the primary, correct? So if I want to define any service load, so I can define the service load. And if I want to define the ultimate load, which means usually we, you know, this two, we will use it, you know, for combination. But right now, or let's say factor load, also we can say that factor load. So service load always, you know, they come up with factor 1 and ultimate. So according to the code, so maybe we need to, you know, apply some factors. But for now, just we will go, you know, for primary load, dead load. And later on here, we have actually, you know, the load combination. So we will reach to this level, and then we will talk about this load combination. That's why here, so I can set everything as primary load type. And then the loading type here, I can say that dead load is under dead load type. Okay, and after that, so from here, I can say add. So you can add it. And then here you have this load case 1. Okay, same thing.
Okay.
Load case number 2, I want to apply the dead load, let's say. So here, sorry, live load. So from here, I can say that LL, which means live load. And then I will change the load type to live load. Okay, and then click add. So right now I have this. Or maybe also I have another type of loading. For example, here, maybe I want to apply the, give me a second, please. Maybe I want to apply the load, let's say in wind load in the X direction, for example. And then from here, I can say that wind in X direction. Okay, and then click add. Okay, so right now I have, let me just, if let's say wrongly you define any load from here and you want to remove, okay, so here, as you can see, if you, you know, just right click, so you don't have any option to remove this load. So for removing the load, so you need to come to here, remove load case. Okay, so that's why I can select this load case and then remove. Yes, yes. Okay, so right now I can remove the file. And again, if you want to create another new load, so either you can, you know, come to here, or again, go back to this option, create new load case. Okay, so I will press on this option, and again, I have this window. Okay, again, light title, I can say that, you know, wind load, wind in X direction, and the direction is wind load, and the type is 3, and then click add. So right now, again, I have this wind X. Okay, now I want to define the load cases. For example, for the first one, I have the load case 1, right click, and then here I have the add column reaction load. Okay?
Okay.
So here I have two options, add column reaction load, and also here I have add point load. So the difference between this and this, so for the first one, so whatever I'm applying or defining will be applied exactly. Let's say if I come back to top view, if I want to apply the column reaction load, so it will be applied exactly to center of the column. Let's say here it is the center of the column. Okay, and the load will apply to here. But if I go to add point load, so means that, for example, I can put the load, for example, somewhere here, or maybe here, or here, not necessarily at the center of the column, or even I can put at the edge of this footing. Okay, so now I can go back to here, and then if I press here, see the first one, I'm going to add column reaction load. Okay, so just to show you. So if I press on this option, so here I have the, the forces and moments. So under forces and moment, I can say that, for example, here, I want to apply a force, let's say in X direction and in Z direction for this column. Okay, for column number 1. So then I can say that, and also definitely I have the vertical load, yeah? So vertical load will be applied perpendicular to the picture, which means from here, correct?
Okay.
So first of all, I will apply, for example, minus 150 kilonewton. So here I have my unit as kilonewton, and here also I have the unit as kilonewton meter. So from here, maybe I want to apply a moment around the X local axis. So then here I can say that, for example, minus 30. Okay, so it is the first load that I want to apply to this column. And then add. See right now, I have this option here. Okay, so again, from here, I can say that the second column, which means here. So for sure, I have the, vertical load. So here, I can change it to 130, let's say. And then moment, maybe I can change it to minus 10.
Okay.
And then also I want to apply moment around the Z local axis. So here, minus, or let's say plus, I don't know, 15. Okay, it is the for the second.
Yes,
okay, and then add. Okay, see here, I have also this one. Okay, so this one, let me just, I think this one is not appropriately defined. So again, I will remove this from here. Remove it, yes, yes.
okay.
Okay. Okay, and then once again, I will select this load. Okay, and then from here, let's say minus 150. And then here, minus 30. Okay, and add. So here I have the second option. So later on, we will assign this. For example, if I want to assign this one to this column, let me to clear everything. So I can select this column. Okay, and then here I have this option. So we said that we want to assign this minus 150 and the moment with minus 30 around the z-axis to column number 1. So then I can say assign load. So select this, and then assign load. Okay, so right now, if I, sorry, just I can say that here I want to assign to selection. Okay, assign to selection. Okay, so right now I can select this and then select this load and then assign load. Okay, if I go back to isolated, see here, I have this load just assigned to this foundation. So we said that this one we can assign to foundation number 2 or column number 2. Again, I can select assign to selection, which means I will select this one and then assign load. Okay, so right now I have this. And the rest, maybe I want to assign another load to be assigned to this 3 foundation. Again, for this reason, so I will come back here, just select this option. Okay, and then from here, I can say that minus, for example, 18. As you can see here, for the Fy, always I'm putting minus. Why? Because of this. Okay, so here I have the y-axis. Okay, so it should be negative.
Okay.
Okay, and then here I want to add one positive 30 and
30.
maybe, yeah, around the my. So I want to assign 25, and then here I want to assign minus 10, for example. Okay, so right now I have something like this, and again, so I can add. Okay, so right now I have this. And from here, I want to assign to, this three foundation. So make sure that here assign to selection is activated, and then assign load. So right now, as you can see here, so just I assign to this footing. So the next one, I will go to live load. Again, right click. I don't want to assign the point load, but just to show you, okay? So here, if I press on add point load, see here, you have the location. You have the location for the load. Okay? So, but here I'm not actually, going to assign this load, but just to understand actually the difference between add load, add column reaction load and add point load. So the differences between these two, once you are selecting the add point load, so you can also add the load to any position. For example, you want to assign here, or you want to assign here. Okay, but once you select the add column reaction force, so which means, so just you are assigning the load to the center of the foundation. Okay, so now from here I can say add column reaction load once again, but it is live load. So from here again, so I want to just for this tutorial, just to assign a live load, to be assigned to all the footing, just to, let's say, save our time. So from here, I can say that, for example, minus 200, okay, and then my, or let's say mz, so I'm going to assign minus 45, and then click add. So here under live load, right now, I have this loading. And then from here, I have two options. So either I can go to assign to view, which means it will be assigned to all the foundation, or I can go to assign to selection, and then I can select this. So it doesn't matter. So I can go back to assign to view, and then this is also selected, and then assign load. So if I assign this, so here I have this live load. And the next one is load case 3, which is wind load. So for this one, I will again right click. Okay, and then from here, I can go to add column reaction load once again. But this time, I'm not going to assign the, let's say, Fy. So because from here, I want to just, consider the effect of reaction of the wind, which is, it can be in the as it can be applied as fx or as fz. So I'm going just to apply, as fx. So that's why here I want to put, let's say, the positive, because here I have the positive direction. Okay, and then here I will put 32, let's say. Okay, and then add. So here I have this fx at 32, and then here I can assign to VU. Okay, so from here I can select assign to VU, the first option, and then assign load. See here, right now I have this loading. If you want to scale the loading, so as we explained earlier in our past videos, so you can go back to home, and here you have the scale setup.
Yes,
Okay, so from here I have the load scales, and the first one is point load. So I can make it smaller, just like this. Okay, see here, I have this. Anyway, so you can just set the load scaling from here. And we did for this, and the next step, so I can just go to sliding and overturning moment. So right now here, I have the sliding factor under dead load. I have the sliding factor under live load, and also I have sliding factor under wind load, and as well as overloading factor. If you want to change this factor, so you can change them. Okay. So for example, here for overturning, let's say, for example, I want to change to 1.5, 1.5, and also 1.5. Okay. But some engineers, they prefer actually, to keep this one as one. Later on, they want to come here and then under, let's say, load combination. So just once they want to consider the factor loads. But here also you can change it, just to show you actually, the possibility in the STAAD Foundation Advanced that you can do. So the next step, so here we have two options for load combination. The first one is the manual one, okay, and the second one is the automated load combination generation. If I go to the first one, for example, here I have the create new load combination from here. Okay, so from, as you can see, from here I can select these three options and then put it here. And from here I can change the load factor. For example, for dead load, I can go for 1.35. Okay, and for live load, I can go for 1.5. And then for wind, maybe I can go for 1.2. Okay, and then from here, I can say add load combination. So here I have load combination number 4. If you just open this, here you have the load combination. But also here, you have the automated way to generate load combination. Yeah, if you click on this, from here, you can see, but unfortunately, again, here, we don't have the Euro code for generating the load combination, because our focus in this tutorial is based on the Euro code, but here we don't have the Euro code. That's why you can go to the user define, or again, you can, for example, go to one of this selected code that you have here, and then you can modify them, but according to Euro code. For example, here, as you can see, I have two options. I have the service load combination, as well as ultimate load combination. So under service load combination, usually always I have the factor as 1, but under ultimate load combination, so usually I have 1 point something, which means here I have the factor load. Okay, so from here I can modify it by myself. Let's say here, first of all, I want to have, for example, 1 service load. So that's why here I can, uncheck all these options and then, select just 1 service load. And same here under, let's say, ultimate load combination, I can uncheck everything under this ASC E716. or simply you can go to user define. Okay, so under user define, I have this service load combination as well as ultimate load combination. So in this way, so I want to select this, let's say, service load combination. I want to have the factor for dead load as 1, and also for live load as 1, and also wind load as 1. Okay, wind load in X direction. So it is the for service load. Let me just, okay, clear everything.
Okay.
And here under ultimate load combination, so again, let's say just talk about the Eurocode. For example, under dead load, I can say 1.35, and then under live load, so I can go for 1.6. Again, here we need to take note that under Eurocode, again, maybe you have different load combination for foundation design. Okay, so the load that I'm putting here is based on the load combination for general structures. Okay, 1.35 and live load 1.6, and then for wind load I can say 1.2. Okay, so from here I can select this. Or since here I have same load factor, see here 1.35, 1.5, and then here I have 1.2. So I created this manually, but here maybe I can change this one to 1. Let's say here I don't want to put the live load, but for wind load I want to put 1.4. Okay, so the load combination first of all should be according to the selected code, and also as an engineer, if you want to combine any loading that you have, so also you can create your own load combinations. So after that, I can, for example, select this, the first one, let's say I can select this, and this, and this, I can generate load combination. Okay, so here, if you come here, so here I have the ultimate load. See here, I have the dead load 1.35, and here I have the wind as 1.4. Okay, again, if I click on here, generate load combination, go to user define. Okay, so here we said that for service load, also I want to add 111. Select this, and then generate load combination. Okay, close. So here also I have the service load. Okay, so here I have the service load, all factor 1, and here I have the ultimate with factor 1.35 and 1.4. And the previous one, the first one also I created using the manual procedure, which means this one, create node load combination. So just we created this, and after that, so if I come to the pile or soil bearing capacity factors, so select on this, and then from here, I have the load title. So here I have the dead load, live load, wind load, and here that one actually was, just manually I created. Maybe I can say that LCOM, which means load combination 1. Okay, so just I want to name it as this. And again, from here, so you can go for different, soil bearing capacity factor under each load case or combination. So from here, I will suggest you, to just keep it as 1. Okay, and then close this. So the last one is actually nothing, variable soil bearing table. And then after that, I can go to create a new job. So then I can go to create a new job. From here, I can say that again, isolated footing. And then the type, we said that from here, I have different type of footing, isolated, pile cap, mat, combined, octagonal, strap, and so on and so forth. I will select the isolated one. So the code, I will select the Eurocode, and default unit type, I will select as SI, and support assignment. So I want to assign to all supports. And from here, I just want to consider the load combinations. And that's why I will select this 3 load combination and then add selected load cases. So here I have this 3 load combinations and then create job. So the rest is same as our previous tutorial on STAAD Foundation Advanced. So you can just, right now you have the isolated footing job. You can expand this, and then also you can expand this. You can go to the concrete and reinforcement option. So from here, I have all the values. Previously, I set it as default. Right now, that's why I have, for unit weight of the concrete, I have 25. And then for minimum bar spacing, I have 100 mm. Maximum bar spacing, I have 450 mm. And all these values that you can see here previously in my previous STAAD Foundation job, I just adjusted or set it as default parameters. So you can also do it, and then you can save it as default. So once you did it, so in the new project that you open STAAD Foundation Advanced, so you will find this saved or stored parameters. So you don't need every time to change them. Okay, you can click on yes to have them as default parameters. So, but just to review them, so here I have the minimum bar size for footing bottom. So I selected as 10 mm, and maximum bar size for footing again at the bottom. So I selected as 25. The minimum bar size for top of the foundation, I selected as 8. And maximum bar size for footing at the top, so I selected as 60. So the next one, I can go to cover and soil parameters. Again, I have all these options for parameters as default. So after changing all these parameters by yourself, so you can change them. And then here, you can set them as default by changing no to yes. So for foundation number 1, as you could see here, I have the pedestal. So that's why here I need also to set the pedestal cover. Maybe here I can say 25 mm. Okay, but for bottom cover for foundation, so I have 40 mm. And the unit weight of the soil, maybe I can say that 20. The bearing capacity of the soil is 150, and the rest, again, so you can review it by yourself. And the most important thing here, you have the type of depth. So we will, actually we talked about this option in detail in our previous tutorial, so that you can find it in our description of this video. And you will find out actually what is the difference between fixed top and fixed bottom. And if you have the depth of water, so if you want to change it, for example, here I can change it to 1 meter. Again, all these options we talked in our previous video, which you can find it in the description of this video. And then after that, you can set as default option. So the next one, you can go to footing geometry. Under footing geometry, again, I have all these options because previously I set all these parameters as default. Right now, also you can, after changing all these values as you desire, and then you can set as default. Okay, but for now, again, I have the minimum length of the foundation. I set it as 1 meter, and minimum width, again, I set it as 1 meter. Minimum thickness, so as 400 mm. Maximum length and maximum width, so we put as 2.5 meter and 2.5 meter. Maximum thickness, so 700 mm or 0.7 meter. And we have the dimension increment along x-axis and along z-axis. Again, you can find all this detailed explanation about all these parameters in the our past video.
Okay.
Okay, so we can go to the sliding and overturning. So here we can accept these values. If you want to change these values, you can change it. And if you want to save it as default, you can save it as default. And after that, so simply you can go to Design tab, and then you can design it. Yes, save. Okay, so let me just isolate it. EC2, and then from here I want to make sure that I'm saving the file in the right folder. Okay, for this reason I will select the folder. Okay, so I'm putting the design file in this folder and then save it. Okay, so if I had any error, so the software showed me the error. But right now, as you can see, so we don't have any error. Everything is fine. Okay, and from here, so I can go to the foundation number 1. So as you could see here, we had actually, the pedestal, and here I have the pedestal as 300 mm that we already defined, and the software just actually, came up with this solution. So which means from here, it just designed as 250 by 250. And here it is the pedestal dimension. And if I come down, so from here, I have all the, let's say, design parameter that I specified during the design process. Okay, but finally, if I go to here, I have the overall design information. So here I have 200 by 200. And then here I need to provide the reinforcement at the bottom. So the reinforcement with 10 mm dia in both directions. Okay, but at the top, so I don't need to provide any reinforcement according to this applied loads. Okay, if I go to detail and schedule, but before going there to detail and schedule drawing, so also you can review all these options that you have in this window. Okay, for example, here I can go to load combination. So here I can see the load combination. So you can, let's say, minimize this window. So here I have the load combination number 1, and also here I have the service load as well as ultimate load combination. If you go to, for example, stability check, so here you have the stability check, and from here you can see the design data for stability check. And then for punching shear, so you can come here and then you will see the punching shear check. Okay, and then here you have the flexural along the x-axis. As we said that you need to provide 21 number of reinforcement with 10 mm dia along the z-axis as well as this along the x-axis. Okay, along the z-axis and x-axis, as you can see in this view. Okay, so in this way you can design your isolated foundation from zero, or let's say from A to Z. using STAAD Foundation Advanced. If you go to detail schedule drawing, okay, from here you will see, all the dimensions from this foundation with the pedestal. You have the reinforcement drawing, and here also you have the link size for the reinforcement. Sorry, for the pedestal. Okay, and for column. Okay, so in this way you can design the isolated footing. And from here, if I go back to footing, right now actually we are under footing number 1 with the pedestal. If I change to footing number 2, so here I have footing number 2. And if you remember, so we said that the column size for footing number 2 was 50 by 50. And then here the software came up with this solution. If I go to footing number 3, remember we said that we have actually the circular column with a diameter of 0.6 meter or 600 mm. So here I have this footing, and here also I have the reinforcement pattern for this footing. And then for number 4, it was 400 mm by 600 mm. And the last one was 400 by 400, if I'm not mistaken. Okay, so it was 0.3 by 0.3. Okay, so in this way you can see the drawing, as well as from here you can also see the general arrangement drawing or GA drawing for different columns. And here you have the overall information with the foundation number 1, 2, 3, 4, 5, the sizes of the foundation. As you can see here, you have different sizes. So for foundation number 1, I have 250 by 250. Foundation number 2, I have 230 by 230. Foundation number 3, I have 240 by 240. Same for footing number 4 and 5. And then from here, if you go back to detail and schedule drawing, so you can save the drawing as the DXF or DWG format.
Okay.
Okay, that's it. It was for designing of isolated footing using STAAD Foundation Advanced. Hope you enjoyed this video.